In this video, we're going to do some examples of finding the slope of a curve at a given point using implicit differentiation. Our first equation is x times the cube root of y plus y equals 10. Let's first rewrite this equation in exponential form rather than radical form. That gives us x times y to the 1/3 plus y equals 10. The first term is a product, so we use the product rule to differentiate. The product rule is f prime g plus g prime f. And in this case, f is equal to x and g is equal to y to the 1/3. The derivative of f is 1, and we multiply that by g, y to the 1/3. That gives us y to the 1/3. That's our f prime g. Now we add to that g prime f. The easier part of g prime times f is the f part. F in this case is x. So I'm going to go ahead and write x out in front of this term. Now we multiply that by g prime. But here g is y to the 1/3 and y is a function of x. So we have to use implicit differentiation here. The derivative of the outside function, y to the 1/3, is 1/3 y to the negative 2/3. And we multiply that by the derivative of the inside function, y, which is dy over dx. Now we differentiate the second term, y. And here again, we'll have to use implicit differentiation. The derivative of the outside function, y to the first, is just 1. And the derivative of the inside function, y as a function of x, is dy over dx. And that gives us 1 times dy over dx, which is just dy over dx. Now, of course, an easier way to look at that is when y is all by itself as a term, the derivative of y is just y prime, or dy over dx. So there's no reason to really look at this as a chain rule operation because it's just y as a function of x. But it still works if you view it as a chain rule operation. The result is still just dy over dx. And that's equal to the derivative of 10 on the right with respect to x, which is 0. And now let's clean the left side of this equation up just a little bit so that it doesn't give us such a headache. There, that looks better. And now we need to solve for dy over dx. But there are two terms on the left side of this equation that contain dy over dx. That's okay. Let's keep both of the terms that contain the dy over dx on the left side of this equation and move the other term over to the right side. So let's subtract y raised to the 1/3 power from both sides of this equation. And that gives us this equation. Now on the left side, let's factor dy over dx from each one of the terms on that side. Factoring dy over dx from the first term leaves us with 1/3 x times y to the negative 2/3. And in the second term, factoring a dy over dx from dy over dx leaves us with 1. And that's equal to negative y raised to the 1/3 power. And now dividing both sides of the equation by 1/3 xy to the negative 2/3 plus 1 gives us dy over dx is equal to negative y to the 1/3 over 1/3 xy to the negative 2/3 plus 1. This is a complex fraction, so we'll need to take a couple of steps to simplify it. The first thing that we can do is multiply the numerator and the denominator of the fraction by 3. Multiplying the numerator by 3 gives us negative 3y to the 1/3, and multiplying the denominator by 3 gives us x times y to the negative 2/3 plus 3. This is still a complex fraction because we have y to the negative 2/3 in the denominator. Let's fix that by multiplying the numerator and the denominator by y to the positive 2/3. In the numerator, that will give us negative 3y. And in the denominator, that'll give us x plus 3 times y to the 2/3. And that's our derivative. In part 2 of this problem, we now want to find the slope of the curve at the given point. And our given point is the point 1, 8. To find the slope of the curve at a given point, we would normally evaluate our derivative at the given x value, in this case 1. But in this example, our derivative contains x's and y's. So to find the slope of the curve at the given point 1, 8, everywhere we see a y in our derivative, we enter the y coordinate of the point. And wherever we see an x, we enter the x coordinate. Substituting 8 for y and 1 for x gives us this expression. Negative 3 times 8 in the numerator is negative 24, and that's over 1 plus 3 times 8 to the 2/3 power. 8 to the 2/3 power is the same thing as the cube root of 8 squared. The cube root of 8 is 2, and if we square that, we get 4. So in the denominator, we have 1 plus 3 times 4, which simplifies to negative 24/13. So the slope of the curve at the point 1, 8 is negative 24/13. Let's find the slope of the curve of cosine of y equals x at the point 0, pi over 2. The first thing that we need is the derivative. Because y is not explicitly defined as a function of x, we'll use implicit differentiation to find our derivative. On the left, we'll have to use a chain rule since y is a function of x. The derivative of the outside function, cosine y, is negative sine y, and the derivative of the angle or the argument, y, is dy over dx. And the derivative of x on the right is 1. Now let's divide both sides by negative sine y to isolate dy over dx. That gives us dy over dx is equal to negative 1 over sine y. Now, if the goal of this problem was to only find the simplified derivative, we would want to go one step further and simplify the negative 1 over sine y into negative cosecant y, so that we would have a fully simplified form of our derivative. But in this example, we're only going to use the derivative to help us find the slope of the curve at 0, pi over 2. So it's probably going to be easier for us to keep this in terms of sine rather than cosecant, since we're going to evaluate the derivative now. Notice that our derivative only contains the variable y. So wherever we see a y, we're going to plug in pi over 2 to evaluate. And the sine of pi over 2 is 1. And that simplifies to negative 1. So the slope of our curve at the point 0, pi over 2 is negative 1.